Hello, this is Yashvin. In this video, I'll be solving paper 2 variant 2 February-March 2021 9701 chemistry. 1. The rate of chemical reactions is affected by changes in temperature and pressure. A1. Draw a curve in the axis on the axis to show the Boltzmann distribution of energy of particles in a sample of gaseous krypton atoms at a given temperature, and label the curve T1 as well as labeling the axis. On the x-axis you have energy, and on the y-axis you have total number of particles with a particular energy. 2. On the diagram in A1, draw a second curve to show the distribution of energies of krypton atoms at a higher temperature, and label this curve T2. The second curve would have a lower peak and a greater area above higher readings of energy. So we have T2. B. The Boltzmann distribution assumes that the particles behave as an ideal gas. State 2 assumptions of kinetic theory as applied to an ideal gas. So ideal gases do not experience any intermolecular forces of attraction, and all of their collisions are elastic as well, meaning no kinetic energy is lost during these collisions. 2 grams of krypton gas is placed in a sealed 5 dm cube container at 120 degrees Celsius. Calculate the pressure in pascals of krypton gas in the container and assume krypton behaves as an ideal gas. You're supposed to show your working as well. For an ideal gas, you'd have used the formula PV, pressure times volume, is equal to number of moles times R times the temperature in Kelvin. So first off, we have the number of moles, which would be equal to the mass or molecular mass. So 2 over the molecular mass of krypton, which is 83.8. Throughout this numerical, I'll be using my answers corrected to 3 significant figures. So this would be 0.0239. And so you'd use the value of N as 0.0239. As for temperature in Kelvin, you'd add 120 to 273, 393 Kelvin. You also need to convert the volume 5 dm cube or 5 liters to meters cube. 1 meter cube is equal to 1000 liters or 1000 dm cube. 5 dm cube would be 5 times 0.001, so that would be 0.005 meter cubed. And so you'd multiply for pressure, you'd multiply 0.0239 times 8.31, the value of R, times the temperature, 393 Kelvin, and divide that with the value of volume, 0.005, and you'd get the answer as 15,600 pascals. Again, my answer is corrected to 3 significant figures. 3. State and explain the conditions at which krypton behaves most like an ideal gas. That would be at a higher temperature and low pressure, where the volume of particles is negligible compared to the volume of gas, and van der Waals forces as forces of attraction are insignificant. And that is so because at a lower pressure, volume of gas is greater, so molecules are further apart, so they're not close enough to experience the force of attraction, which would be insignificant at low pressure. Similarly, at high temperature, molecules have energy, so they move and gather distance between themselves, and so they do not experience intermolecular forces. Whereas if you increase the pressure on a real gas like krypton, its volume would decrease. The volume of molecules of krypton would not be negligible compared to the volume of the gas, as it should be for an ideal gas. Krypton reacts with fluorine in the presence of ultraviolet light to make krypton difluoride, and the activation energy as well as enthalpy change of formation of krypton fluoride is given. As you can see, the enthalpy change of formation is positive, meaning that this reaction is endothermic, and therefore the products would have energy greater than the reactants on the energy profile. 1. Use this formation to complete the reaction profile diagram for the formation of krypton difluoride. Label the activation energy and enthalpy change of formation on the reaction, assume the reaction proceeds in one step. A value of activation energy greater than the value of reactants, as well as the greater than the value of products. And the products would be at a higher energy level than the reactants, so that would be here. This label over here is the activation energy, and the difference between energies of reactants and products is the enthalpy change, which is the enthalpy change of formation of krypton difluoride. To explain in terms of activation energy and collision of particles, how an increase in temperature affects the rate of a chemical reaction. Increasing the temperature increases the energy of particles in a chemical reaction, and that means now most of them are going to have energy greater than the activation energy, which is the least amount of energy for collisions between particles to be successful, meaning that since most of the molecules have energy greater than activation energy, collisions between most of the particles are going to be successful, leading to a greater frequency of successful collisions that leads to reaction. 2-chlorine is a reactive yellow-green gas. It is a strong oxidizing agent. A. State how chlorine is used in water purification. It's used to kill microorganisms like bacteria present in the water. B. Chlorine has the highest first ionization energy of the P3 element of the period 3 elements from sodium to chlorine. 1. Construct an equation for the first ionization energy of chlorine and include state symbols. So that would be removing an electron from gaseous atoms, from 1 mole of gaseous chlorine atoms. And so you have the state symbol, and you remove an electron to form a positive chlorine ion, which would be in gaseous form as well. To explain the general increase in first ionization energies of period 3 elements. So the first ionization energy increases across the period because as you go across the period, the nuclear charge or the number of protons in the nucleus increases, and therefore nuclear attraction for outer shell electrons also increases, meaning that it becomes harder and harder to remove that first electron, and shielding effect remains the same since the number of shells does not increase. The halide ions show clear trends in their physical and chemical properties. 1. State and explain the relative thermal stabilities of hydrogen halides. The thermal stability is due to the bond between hydrogen and the halogen, and this bond gets weaker and weaker as you go down the group, because going down the group means addition of shells to the atom, which increases the size of the atom, and as a result of that, the bonding pair of electron between hydrogen and the halogen gets farther away from the nucleus of the halogen atom going down the group, which decreases its attraction, making it easier to break the hydrogen-halogen bond and therefore decreasing the thermal stability. The halide ions react easily with concentrated sulfuric acid. The main sulfur-containing product of each of the reactions is shown in the table. So the main sulfur-containing product of reactions with each of these halide ions is different, as you can see, and we're supposed to complete the table to show the oxidation number of sulfur in each of the sulfur-containing products. Starting with the sulfur in the first product, you have the hydrogen sulfate ion. Now, in the first step, you're going to write down the oxidation state of each of these elements. Sulfur oxidation state of sulfur is unknown, so I'd write X for sulfur. Hydrogen has a charge of +1, oxygen has a charge of -2, and since there are 4 of oxygen atoms, we'd have -2 times 4, and the sum of that gives the charge of the ion, which is -1, and this forms an equation x plus 1 minus 2 times 4, which is equal to 1, and when you solve that, you'd have -1 plus 7, which is equal to positive 1, and therefore the oxidation state of sulfur is positive 6 over here. As for sulfur dioxide, similarly, you have sulfur oxidation state of sulfur is unknown, whereas oxidation state of oxygen is -2, and you multiply that with 2 as there are 2 atoms, and you equate that with 0 since the compound has no charge, and so x is equal to +4 when you shift the bracket. Now coming to hydrogen sulfide, you have 2 of hydrogen. You have again x unknown, sulfur oxidation state plus 2 times 1 because the oxidation state of hydrogen is 1 and there are 2 of them, which is equal to 0 again because this is a neutral compound, and therefore x is equal to -2. Explain why the different sulfur containing products are produced when each of these halide ions reacts with concentrated sulfuric acid. As you can see, going down the group from chlorine to bromine to iodine, oxidation number of sulfur decreases from +6 to +4 to -2, as in the sulfur gains electron to get reduced, and for sulfur to get reduced it would have to act as an oxidizing agent and going down the group it is going to oxidize each of these halides, but removing an electron from each of these halides becomes easier as you go down the group because number of shells increases and therefore the nuclear attraction for outer shell electrons decreases, and therefore it becomes easier to remove that electron. The chlorine reacts with aqueous sodium hydroxide in a disproportionation reaction. One state what is meant by disproportionation. In this reaction, a species is both oxidized and reduced. To write an equation for the reaction of chlorine with sodium hydroxide, with cold sodium hydroxide. Sodium chloride, you have a chloride ion with a charge of -1, and sodium chlorate has chlorine with a charge of +1. So you go from 0 in chlorine neutral molecule to -1 and to +1. The chlorine gains an electron and loses an electron to become oxidized and reduced. Aluminium reacts with chlorine to form aluminium chloride. Aluminium chloride can exist as the gaseous molecule Al2Cl6 gas. This molecule contains coordinate bonds. One, draw a diagram that clearly shows all the types of bonds present in aluminium chloride. In this diagram, you might be tempted to draw the dot and cross diagram, but you do not need to do that since it's not asked in the question. You only have to draw a diagram which shows the name of elements, the symbol of elements, and the bonds between them. So to start, I draw two aluminium symbols and a chlorine symbol above and below in the space between them, and then a chlorine symbol at the corner of each of the two aluminium atoms. Now, there is a codative bond between a chlorine atom and an aluminium atom, and I'd use the center chlorine atoms. Supposing I use the top one for this atom, for this aluminium, that would mean I'd have to use the bottom chlorine atom for the aluminium atom on the right hand side, and rest of the chlorine aluminium bonds are all simple covalent bonds. And that is it. To describe what you'd see when sodium chloride reacts with water and name the type of reaction that occurs, the solid would dissolve and so it would disappear, and since aluminium chloride has covalent bonding, it is a hydrolysis reaction. If 0.02 mole of element Z reacts with excess chlorine to form 0.02 mole of liquid chloride, the liquid chloride has formula ZClN, where N is the number of chlorine atoms in the compound. ZClN reacts vigorously with water at room temperature to give an acidic solution and a white solid. When excess silver nitrate is added to the solution, 11.454 grams of silver chloride forms. One suggests the type of bonding and structure shown by ZClN. The only period 3 chloride that forms a solid N in acidic solution after reaction with water is silicon chloride, and silicon chloride has covalent bonding. To calculate the value of N in ZClN. Okay, for this I'd like to write the equation for the reaction between Z and chlorine. You have 0.02 mole of Z that forms 0.02 mole of Z chloride. You're also given that when silver nitrate is added to this solution of Z chloride, 11.54 grams of silver chloride forms. Now you need to use this mass of the compound that forms to calculate the number of moles of the compound that forms, which would be equal to the number of moles of chlorine present in the compound. And to do that, you divide the mass of the compound with the molecular mass, adding up the atomic masses of each of these elements. So that is 35.5 for chlorine and 107.9 for silver. This would give the number of moles as 0.08 mole, which is the number of moles of silver chloride, and therefore this is also equal to the number of moles of chlorine present in the compound. Now this chlorine comes entirely from the chlorine present in Z chloride, and therefore 0.08 moles of chlorine atoms is present in Z chloride. Because we know that there is a total of 0.08 moles of chlorine in the compound, that means the total number of moles of chlorine in the product has to be 0.08, which as given in the question is 0.02 times N over here, and therefore N is equal to 0.08 divided by 0.02, and that gives the answer as 4. Dichloromethane is widely used as an organic solvent. Dichloromethane can be prepared by reacting chloromethane and chlorine at room temperature. The reaction proceeds via several steps as shown. So you have initiation, propagation, step 2, and then the final step. 1. Give the name of the mechanism of this reaction. This is free radical substitution reaction, as it involves the reaction of radicals. 2. State the essential condition required for the initiation step to take place. This requires energy in the form of ultraviolet light or sunlight. 3. Give the electronic configuration for the chlorine radical. Since this is a neutral chlorine atom, it would have 17 electrons. It is just a radical, meaning it has an unpaired electron. That gives the total number of electrons as 17. 4. Identify the products of the step labeled propagation 2. In this reaction, the chlorine molecule forms 2 chlorine radicals, one of which reacts with this radical to form CH2Cl2 or dichloromethane, and the other chlorine radical remains as the second product. 4. Name the type of reaction shown in the final step. It is a reaction between two radicals and therefore it is termination. 4. Suggest the identity of another organic molecule that is a product of reaction of chloromethane and chlorine under the same conditions. In free radical substitution reactions, the carbon-hydrogen bond is replaced by carbon-chlorine bond because the carbon-hydrogen bond is weaker. And so after dichloromethane has formed, you still have 2 carbon-hydrogen bonds in the compound. You can replace those bonds with carbon-chlorine bonds, and so if you do that, that would give you a new compound with the formula CHCl3 with single carbon-hydrogen bond. Three compounds P, Q, and R have all been found in the atmosphere of one of Saturn's moons, A. The equation for the complete combustion of P is shown. The enthalpy change of formation of carbon dioxide is negative 384 kilojoule per mole. Calculate the enthalpy change of formation of P in kilojoule per mole. Here you need to draw the Hess cycle. To do that, I'll draw boxes around the reactants and the products, and the third box below them. Now, because this Hess cycle uses the values of enthalpy changes of formation, you draw the arrows from the third box, which we'll be using for the elements, to the reactants and the products boxes. Now, each of these boxes represents a stage. Let's label the stages 1, 2, and 3, right? In the element boxes, you'd have carbon, nitrogen, oxygen. Now, enthalpy change of formation of carbon dioxide is given in the question as negative 384, and since that is forming on the product side over here, you would label that using the arrow on the product side. So that would be negative 384 times 4, because as you can see, 4 moles of carbon dioxide are forming, and the value, this negative 384, is for 1 mole. Similarly, the arrow going from the box 2 to box 3 represents the value negative 2036, which is the enthalpy change of reaction, and the enthalpy change of formation of P is X, using the arrow going from box 1 to box 2, since you form P on the reactant side. Now you have the start and the end. That means when you go from box 1 to 2 and from 2 to 3, the energy changes would be equal if you had gone from box 1 to 2. And so that means from 1 to 2 you have X, and going from 2 to 3 it is negative 2036, which is equal to going from 1 to 3 directly, which is 4 times negative 384. You might be wondering about the values of oxygen and nitrogen. They are not included because these are elements and not compounds. And solving this equation would give you the value of enthalpy change of formation of P as positive 500 kilojoule per mole. One of the products of complete combustion of P is nitrogen. Explain the lack of reactivity of nitrogen. It is due to the strong triple bond between nitrogen atoms in a nitrogen molecule. BQ forms when hydrogen cyanide reacts with ethine. Ethine, hydrogen cyanide are all hydrogen cyanide, and Q are all weak Bronsted-Lowry acids. Explain what is meant by the term weak Bronsted-Lowry acids. They would be proton donors that do not fully dissociate into ions when in solution, or in other words, that give a low concentration of hydrogen ions in solutions. 2. Ethine, hydrogen cyanide, and Q all contain triple bonds between two atoms. A triple bond consists of 1 sigma and 2 pi bonds. Draw a label diagram to show the formation of a pi bond. A pi bond forms between two p orbitals that overlap sideways. So this is the first p orbital, and this is the second p orbital with a plane, and this forms the pi orbital as the product. C. P and Q can be detected in the atmosphere by infrared spectroscopy. Identify two absorptions and the bonds that correspond to these absorptions that will appear in the infrared spectra of both P and Q. And so you need to find the absorption values of bonds that are present in the structures of P and Q. And so those two bonds would be the carbon-carbon triple bond and the carbon-nitrogen triple bond. Both of P and Q also have carbon-carbon single bond, but the value of absorption is not given in the data booklet, so we'll be using the rest of the two bonds. D. The flowchart shows some reactions of R. 1. Name the type of reaction shown in reaction 1. So reaction 1, you have polymerization, and since it is only using one monomer, this would be addition polymerization. 2. Draw the structure of S, the organic product of reaction 2. Reaction 2 uses ecosulfuric acid with heat under reflux, which is the requirement for hydrolysis, and that would hydrolyze the CN group, whereas the rest of the structure would remain the same. And so you have 3 named T. So T over here has an amine group on the first carbon atom in a 3 carbon chain, in a 3 carbon atoms chain. So that would make it propyl 1 amine. 4T can also be formed using the formed by the reaction of 1-bromopropane with ammonia. State the necessary conditions for this reaction. You'd have to use ammonia dissolved in ethanol under high pressure. 4-hydroxyethanol has been observed in dust clouds near the center of our galaxy. A. Predict the bond angles X and Y in the diagrams of hydroxyethanol. X would be 109.5 since carbon forms 4 single bonds, and Y would be 120 since this carbon atom has a double bond. B. Hydroxyethanol reacts with 2,4-dinitrophenylhydrazine and with Tollens reagent. State what you would observe in each reaction. In the first reaction, you'd have orange precipitate, and in the second one, you'd have silver precipitate. C1-hydroxyethanol is converted to ethene dioic acid when it reacts with excess acidified dichromate ions. State the role of acidified dichromate ions in this reaction. So the reagent oxidizes, acting as an oxidizing agent. 2. State and explain any other necessary conditions for this reaction to be successful. The product of this reaction would have acid on this side of the molecule as well as on the left side, meaning that not only would you oxidize the aldehyde, but you'd also oxidize the alcohol. And for the reaction to be completed to form acid and not just aldehyde, you'd have to use heat under reflux to complete the oxidation. Dihydroxyethanol can be reduced to ethane 1,2-diol as shown. Write an equation for the reaction of hydroxyethanol to ethane 1,2-diol. Use hydrogen in brackets to represent an atom of hydrogen from reducing agent. To go from hydroxyethanol to ethane 1,2-diol, you need 2 hydrogen atoms, as one would be added to form an alcohol group and another to form the carbon-hydrogen bond. To identify a reagent for this reduction reaction, so a reducing agent for the reduction process can be sodium borohydride. Ethane 1,2-diol also forms when an alkene A reacts with cold dilute acidified manganate ions, name A. So A would have to have 2 carbon atoms with a double bond between them, which would mean A is ethene. And this is it. We are done with this paper. Thank you for watching.